Welcome. So there's two problems, and both of them are to do with the thing called impulse. A particle is acted on by a force of 12 newtons that acts in a negative direction. The force acts for 5 seconds. What is the impulse of this force? So here we have our particle. And I know that the force of 12 newtons acts in the negative direction, so I might call it minus 12 because it's on a number line, it's in the negative direction. And here we have at t equals 0 seconds, and then at some time later we'll be somewhere on the number line. I'm going to draw it to the right, it makes really no difference. And we have t is equal to 5 seconds, and I'd like to know what the impulse is. We still have minus 12 newtons. And impulse is equal to the force times the duration, force times the change in time. And for this problem, which is on a number line, only one dimensional, I have a constant force which is minus 12 newtons, and I have a duration which is 5 minus 0, or 5 seconds. So this would equal minus 60, and the units would be Newton seconds. So there's my impulse, and I can find my answer there. So on a number line, you've got to take into account the direction that the force is applying. Is it to the left or to the right? And then you take into account the duration, and you can work out the impulse. This lower problem is a three-dimensional problem, and it says a particle is acted on by a force. So here's a particle. Let's visualize the force acting on it. And this is 3I plus 2J plus 4K newtons. And the force acts for 4 seconds, so T is equal to 0 seconds. And then we have some stuff going on, and over here we say T is equal to 4 seconds. And I'd like to find out what the impulse is. Well, impulse is equal to the force times the time. The impulse is then a vector, and force is a vector. A vector times a scalar is a vector. So this is going to be 3I plus 2J plus 4K newtons. I'm sorry. It is newtons, but I'm not finished. Times my time, and my time is from 4 seconds minus 0 seconds, which is times 4. So then I can say my impulse, my vector impulse, is equal to, well, 4 3s are 12, that's going to be 12I. 2 4s are 8, that's going to be plus 8J. And then 4 4s are 16, so that's going to be plus 16K. And this would be Newton seconds. So there we have the vector impulse in 3 dimensions using IJK notation. So there we have it.